most plant.
Hello dear students, good morning, welcome to Maths IPE classes by NEET World. This is your Abhilash Sir. So today we will continue our discussion on probability. In the last class, we started with probability and we discussed very important theorems, that is,
This is less affected.
probability, function theorem and the theorem of Bayes theorem, okay, statement and also the proof, correct? And also we solved some questions on what is that Bayes theorem, application of Bayes theorem. We solved 2 questions. So today we will continue with the application of Bayes theorem. We will solve one more question and then we will study what is conditional probability, what is multiplication theorem, their proof on multiplication theorem, and some more important questions we will do, and we will wind up with the chapter of probability. Okay, so whatever the questions we are solving in this class and the previous class, that is more than enough for your IPE examination. Okay, and I will also be doing shorts on some important concepts of probability so that you remember better. So please do watch those shorts. Please stay tuned for the shorts also. Please go through that. That will help you to retain better. Okay, where I will be discussing some key concepts in a very short period of time. That will be highly effective if you revise well and if you go through it well. Okay, all right friends. So today we are doing probability, that is from the Maths 2A subject. Okay, Maths 2A, that is part 2A. So let us continue with the discussion friends, and later in the day we will be doing Maths 2B, where we will be starting with important and high factor of integration. Okay, so let us start friends. Let me check if I am audible. That is part 2A. So let us continue. Okay, all right, done. And we have already told you how to download the soft copy. Okay. So we are here probability, and then we have to do random variables and probability distribution. That is the last of Maths 2A LAQs. Then later we will be doing SAQs and also VSAQs. Clear? So let us start with probability now. Okay, everything.
What is
Before this question, we will see one more question, that is having application of Bayes theorem.
is affected?
Look at this question friends. Everyone please look at this question. Please do share the classes with your classmates and friends. Okay, it will be highly beneficial. Okay, I hope all of you are doing your practical exams well. That is highly important. But along with that, don't leave, stop studying for IPE, because practical exams it will go on. But along with that, please give some time for your IPE also. Okay, then you can resume with the IPE classes very well after the practical exams are done. Okay, so pre-boards will be also be going on. Please prepare well. Please use the classes efficiently. Please revise well. Please watch the classes again and again. That will be highly beneficial to you. So let us start with the discussion friends. So what they have given, see here, one box is, see, 3 boxes numbered 1, 2, 3 contain balls as follows. Okay, 1, 2, 3 boxes. Okay, white, this should be white. Okay, white, black, red. Okay, number of balls are given, white, black, red. One box is randomly selected and a ball is drawn from it. If the ball is red, then find the probability that it is drawn from box 2. Okay, what is that they are asking? They are asking the probability that the ball is red. What that it has come from the box 2, that is B2, that is box.
Potential represents the
Based on what? These based on 2. These again based Bayes theorem friends. So clear. So let us solve this question.
What?
Let us solve this question. Let us take down the details.
Influenced by.
So see here, first what they have given. Okay, what is that they have given? They have given that. So
For what?
3 boxes. Okay, 3 boxes.
It is
Box 1, box 2, box 3.
or water molecule.
Okay. White. Okay.
Moving.
This is what?
Can I say that?
White, black and red. Correct? White. This is 1, 2, 4. This is what? This is 2, 1, 5. This is 3, 1, 3. This is what they have given. Now, let us write down. We have to divide the event. Okay. Let B1 be the event. Okay. Let event B1. Let event B1. We should write it as let event B1. Let event B1. Selecting a ball from what? From what is that? From box 1. Similar to the previous question, that is earn question. Let event B2, B3. Okay, selecting. You have to define this. Every step carries marks. Selecting a ball from box 2, B3. Selecting a ball from box 3. Okay, this is the event. Okay, this is the event. Let R represent selecting a red ball. What is that? R represent, because they are talking about what? They are talking about red ball. Ball is red. Selecting a red ball. Red ball. Okay. Now see here, friends. If I talk about probability of B1. Okay. Out of the 3 boxes, 1 box can be B1. So that is what? 1 by 3. So probability of B1 will be.
Statement. You all has to understand.
Boxes. There are 3 boxes. After that, 1 box means 1 out of 3 boxes. Similarly, if I write probability of B2. Okay. Probability of B2 will be equal to how much? Probability of B2 will be equal. Here also it will be 1 by 3. Similarly, probability of B3 will be equal to 1 by 3. This is what we got. Now, the red ball, the probability of red. So, draw. It can be from box 1, box 2, box 3. So, let us write probability of red ball, getting the red ball. Okay. If you talk about the red ball, focus here. Probability of red ball from box 1. Similarly, probability of red ball from box 2. Similarly, probability of red ball from box 3. You have to write it. Okay, red ball from box 1. Observe very carefully. Red ball from box 1. So, box 1. Okay, box 1 is having red ball, 3 red balls. Total balls are how much? 3 plus 2, 5. 5 plus 1, 6. Correct? No? 5 plus 1, 6. So, this will be equal to what? This will be equal to 3 by 6. 3 by 6, what I can write it? So, this will be 3 by 6. I can write this as cancel. I can write this as 1 by 2. Okay, 3 out of 6 are red balls in what? Box 1. What about box 2? 1 out of, what is it? 1 out of 1, 2, 3, 4. 1 out of 4. 1 out of 4. See here. This is what we are focusing on. This is box 3, 3 out of 12. So, this is 3 out of 12. 3 by 12. 5 plus 4, 9. 9 plus 3, 12. So, this is 3 out of 12. This I can write it as what? 3 ones are, 3 fours are. So, this will be equal to 1 by 4. 1 by 4. This is what we got, friends. This is what we got. Now, the important step. Now, the highly important step. So, now you have to write it as, see here. Now, you have to write it as, see here. What they are asking. By applying Bayes theorem of probability, by applying Bayes theorem, okay, by applying Bayes theorem, okay, we have, what is that we have? We have to get what? We have to get probability of getting a red ball from box 2. Okay, probability of getting a red ball from box 2. Probability of getting a red ball from box 2. This is equal to what? As per the Bayes theorem,
change in the volume, water, volume
into
same. Now, how can I bring this back?
This is what we have. Probability of R by B2, this is what we have. Down, we should write probability of R, summation R. Okay. So, this will become equal to what? So, this will become equal to probability of, see here, observe carefully. Observe carefully. Let me move it slightly. So, see here, divided by, this entire thing divided by. So, see, this will be probability of B1 into probability of R by B2, R by B1. Similarly, probability of B2, probability of R by B2, all the 3 you have to write it. Okay, summation of this. Probability of B2 into probability of R by B2. Next, probability of B3 into probability of R by B3. This is what you have to write it. Okay. Now you have got all the values. Now you have got all the values here. Okay. So just you have to put the values here. So this is by Bayes theorem. This is my very important step. This is my very important step. This Bayes theorem you have to apply and you will get this. Now you have to just put the values. You have to write the Bayes theorem. By applying Bayes theorem, definitely you have to mention it will carry 1 mark. Okay, this you have to write the step. Now see here, just put the values. Probability of B2, probability of R by B2, everything is there. B2 is what? 1 by 3. So let me write it here. This implies, let me write it here. Okay, probability of B2 by R. B2 by R is equal to probability of the is what? 1 by 3 into probability of R by B2. Probability of R by B2 is 1 by 4. Okay, this entire thing divided by, what is that? This will be probability of B1 is what? 1 by 3 into probability of R by B1. Probability of R by B1 is 1 by 2 plus this will be 1 by 3 into 1 by 4.
Increase the water.
Probability of B2 into R by B2 already here. Okay, next we have to see what? Probability of B3 is what? 1 by 3.
Say
What is that? Probability of R by B3. Probability of R by B3 is also 1 by 4. Okay, now you got to calculate this. Okay, now you got to calculate this. 1 by 3, 1 by 2 is there. Okay, 1 by 3, 1 by 2 is there. So see here, I have 1 by 4 here, 1 by 4 here, here also 1 by 4. So here also if I make it 1 by 4, I can take something common. So to make this 1 by 4, what I will do? I will multiply and divide by 2. So this I will make it as what? This I will make
what happened? Make it as solute potential over the
S2.
solute.
Just 1 by 3. I divide and multiply.
Solute. Water potential remains.
1 by 4 also is there here. Okay, 1 by 4 also is there here. So 1 by 4, 1 by 4, 1 by 4. Now I can take what? I can take 1 by 4 common. So it will become very easy for us. So I can take 1 by 4 common here. So see here carefully. So if I take probability of B2 by R, 1 by 4 if I take common, 1 by 4 into 1 by 3, this divided by 1 by 4 common means this will be 1 by 3 plus 1 by 3 plus 1 by 3. This is what we have. Now 1 by 4 I have taken common. Okay, so this will be equal to what? 1 by 4 if I take common, this is out. 1 by 4 I can write it. Now see here, this will become what? This will become 2 by 3, correct? No, this will become 2 by 3, not 1 by 3, this will become 3. Now if I take LCM, this will be 3, okay, 2 plus 1, 3, 3 plus 1, 4. Okay, what is at the top? This is 1 by 3, 1 by 3. So this will be equal to what? If I take this up, this will become 3 will go up, this will be 4 will be here. 3 cancel, I will have 1 by 4. So finally 2 by,
and this will be the PTOL. This part is the PTOL and this is the
1 by 4. 4 I got. Okay, clear? So finally got
PTOL. That zone named as decision.
1 by 4. So again by applying Bayes theorem, we got the answer. So see here, let us verify the answer. What is the answer that we got here? So here also it is 1 by 4. See here also it is 1 by 4. 1 by 4 and here also it is 1 by 4 we got. Here also it is 1 by 4 we got. Now observe here. See here everyone. Please observe.
Longer leaf never fall down.
This is the complete solution of this question. This is a complete solution of this question. Please have to write down everything like this. Each step carries marks. Then by applying Bayes theorem, you have to write down this. Then whatever you wrote down here, okay, just you have to apply the values here, put the values here and calculate. Here I made it simplified because I wanted to take 1 by 4 common. So here I had 1 by 2. So I divide and multiply by 2, I will get 2 by 4. Correct? No? So let 2 be here, 1 by 4 I will take it outside, this will become 2 by 3. That's it. So on simplifying this, I will get it as 1 by 4 friends. Is it clear all of you? I hope it is clear. This is the way we solve this question. Clear? Alright friends. Then one more question is there which I want you to write down, that is based on total probability. That is based on what? Total probability. That is based on total probability. Let me take up the question. It's not in your book, but that is the reason I wanted to attend class. Certain important questions we will be doing it in the class also. Okay, let us take up that question. What is the question says? They are saying, see here, A, B, C are three horses in a race. Okay, A, B, C are 3 horses in a race. Three horses in a race. Okay, the probability of A to win the race is twice that of B twice that of B, and they are telling, and the probability of B, and the probability of B, the probability of B is twice that of C. Okay, they are asking what are the probabilities, of A comma, very important, A comma B and C to win the race. This is the question, friends. Okay, this is the question. Please have a look at it. This is the question that they have given. Okay, all right. Observe the last question that they have given. I hope it is visible to all of you. Please have a look at it. So they are telling, look at this. Let us do the solution now. Solution. So see here, A, B, C are 3 horses in a race. Okay, the probability of A to win the race is twice that of B. Okay, and the probability of B is twice that of C. What are the probability of A, B, and C to win the race? So let us write down what is given. What is given now? Given is that probability of A is twice that of probability of B. This is what is given. Similarly, probability of B is twice that of probability of C. Okay, twice that of probability of C. Okay, twice that of probability of C. Now, see here, instead of this, let me write it like this. Given, let me write it like this. This is 1, and also probability of B is twice that of probability of C. Okay, now if I combine this, I can write it as what? Probability of A, okay, is equal to what? I can write it 2 times. Okay, probability of B is what? Probability of B is 2 times probability of C. I can write it as 2 times probability of C. Okay, what I can write? From 1 and 2. From 1 and 2, I can write it like this. From 1 and 2. Okay, from 1 and 2, I can write it like this. So this will become what, friends? Probability of A is 2 2s are 4. So 4 times probability of C. Probability of A is 4 times probability of C. Okay, 4 times probability of C. Probability of A is 4 times probability of C. Probability of B is, what is it? This is 2. This is, let me write it as 3. Okay, let me write it as 3. So probability of A is 4 times probability of C. Probability of B is 2 times probability of C. Now they are asking what does it mean? Probability of A, B, C to win the race. They are asking
Closed during
A is equal to how much? Okay, probability of B is equal to how much? Okay, probability of C is equal to how much? So suppose, let me write down here for you to understand. Suppose E1, E2, E3 are some events. Okay, so the what is that? Total probability is given by total probability is given by P of E1 plus P of E2 plus P of E3 will be equal to always equal to 1. Okay, it will be always equal to 1. This is nothing but total probability. This is what I meant by total probability. Here let us apply total probability. Therefore total probability, okay, therefore total probability is equal to 1. Okay, that means what? That implies, see here, that implies, let us write down here, that implies probability of A, plus probability of B plus probability of C will be equal to what? Will be equal to 1. Now let us write down all the probabilities in terms of C, because see here we have probability of A in terms of C, probability of B in terms of C, and then probability of C directly we can write it. So probability of A is what? 4 times PC. So probability of A is what? This implies 4 times probability of C. Probability of B is what? 2 times probability of C. This is 2 times probability of C. This is directly probability of C only. Okay, 2 times probability of C. This is probability of C itself. This is 1. How you have to write down here? Using 2 and 3. Okay, using 2 and 3 you have to write it. Okay, in brackets. Therefore using 2 and 3 you have to write the reason why. See here, what does 2 say? Probability of B is 2 times probability of C. What does 3 say? Probability of A is 4 times probability of C. That is what should do. Okay, that is what you have to mention here. Very important to mention this. Now let us see, calculate this. 4 plus 2 6, 6 plus 1 7. So 7 times probability of C is equal to 1. So probability of C is equal to what? 1 by 7. Okay, 1 by 7. Okay. Also we know that probability of A is 4 times probability of C. Okay, 4 times probability of C. Okay, 4 times probability of C. Okay, so probability of A will become what? Probability of A will become 4 times into 1 by 7. 4 times into 1 by 7. What is the 4 times into 1 by 7? That is nothing but 4 into 1 by 7. That is nothing but 4 by 7. Okay, we know that probability of B is nothing but 2 times probability of C. This is what
Anyway.
Okay, this is what we deduce. Okay, so this is equation 3, this is equation 2. Okay, so we have from 1 and 2. From where we write it? From 2 and 3, not 1 and 2. From 2 and 3, we have this one. So see here, probability is 4 times probability of C, probability of B is 2 times. So this is equation 2, this is equation 3, what it says. Okay, now see here, that is what equation 2 is here. See here, this is equation 2, this is equation 3, that's it. Now see here, what we will do. Now see here, 4 by 7 we got probability of A. Probability of B will be what? Probability of B will be 2 into probability of C, that is 2 into 1 by 7, that is 2 by 7. Now write down, therefore in the final answer, probability of A is equal to, what is it? 4 by 7. Probability of B is equal to, what is it? Is it 2 by 7. Probability of C, what we got? That is 1 by 7. Okay, it's what? 1 by 7. So the final answer, friends. This final answer. So this is on total probability. This is a question based on total probability. Okay, so this is how we have to solve it. Okay, so using this relation, okay, we will get total probability will be always equal to 1. So this, using this equation, we can deduce the values of probability of A, probability of B, probability of C. Clear? This is how you have to solve this question. Very easy question. Okay, please don't do such questions. Questions on total probability are very easy. Okay, got it, friends? This is how we got to solve this question.
It uses.
Can we move to the next question? Okay, all right. Let us move to the next question, friends. Now we will be doing question on condition probability and will be different theorem.
Strength.
Okay.
Oxalase, pyruvate R.
This also
Bikinase, NAD malic.
conditional probability and multiplication theorem. Okay, let us solve this question first.
That carbon.
Let us solve this first. I think this is based on addition theorem. So see here. Just a minute, friends. The sixth question is very important. They have given some values. See, they are telling the probability of 3 events: probability of A, probability of B, probability of B, C. Okay, 3 events such that A intersection B is this much, A intersection C is this much. Okay, A intersection B intersection C is this much. This is what they have given. Okay, this is what they have given. Observe carefully. Okay, this is what they have given. Observe carefully. Now they are asking, and probability of A union B union C is greater than or equal to 0.75. Okay, they are asking, show that the probability of B intersection C, okay, probability of B intersection C lies in the interval, this interval. Okay, this is what they are telling. They were asked in May 2022. So let us start with the discussion on this question. Okay, let us start with the discussion on this question, friends. Okay, let us start with the discussion on this question, friends. Let us take it here. What is that they have given? Let us write down. Let us write down what is that they have given. So they have given us what? They have given us that. So see here, they have given that. Given what is that they have given? They have given probability of A. Let us write down what is given. Probability of A is 0.3. Probability of B is what is 0.4. Probability of C is what is 0.8. And also probability of A intersection B. Probability of A intersection B is what? It is 0.09. Probability of A intersection C is what? It is given as 0.28. Okay, please write down the values correctly. Don't do the mistake while writing the things that they were given. A intersection B intersection C is what? You should be very careful here. It is 0.08. Then, and probability of A union B union C, A union B union C is given as what? Probability of A union B union C is given as equal to or it is greater than or equal to 0.75. This is what they are telling. Okay, we have to find that, we have to show that this is probability of B intersection C lies in 0.21 to 0.6. Okay, now let us start with the discussion, friends. Now let us start with the discussion. So see here, let us start with the discussion now. Let us brush this aside. So see here, for any event we know that probability, by definition of probability itself we know that the probability of any event always lies between 0 and 1. It can be 0, it can be equal to 1, but it can never be less than 0, it can never be greater than 1, correct? No. So for any event, first write down, for any event, okay, for any event, probability lies between 0 and 1, lies between 0 and 1. Now let us take this, consider what is that? This you have to consider probability of A union B union C. Okay, probability of A union B union C. Okay, so probability of A union B union C, okay, this will always be less than or equal to 1 but greater than or equal to 0, correct? No, less than or equal to 1 but greater than or equal to 0, but here they are telling it is greater than 0.75. they only told, okay, they only told it is greater than 0.75 and it is less than 1. So let me write this as 1, let me write this as 2. So what I will do,
Only included in the transport of the
write
word.
it. So 1 into 2, what does transport it? 1 says that it is greater than 0.75, okay, and 2 says that probability of an event always lies between 0 and 1, so this is less than or equal to 1. So this is what I have written. Please write it like this. Okay, now for this we can apply, definitely we can apply what? We can apply addition theorem on probability. Now by addition theorem on probability, addition on probability, okay, just here this will be 0.75, this will be greater than 0.75 itself, so 0.75 less than, this one I can write it as what? This one I can write it as, for this you can apply addition theorem, this will become addition theorem. In the previous statement and theorem also we proved, okay, statement we wrote and then theorem is proved, okay, P of B plus P of C minus, what is it? It is
So
P of A intersection B, okay, minus P of B intersection A, okay, P of B intersection A, that is what, and correct? No, P of B intersection A, okay,
that
plus P of
no
C intersection A,
third one.
P of, what is it? P of A intersection B intersection C, this will be less than or equal to 1. It should be plus, the last value should be plus, friend, this should be plus. So now we have to write down the values, just put the values, whatever the values is given, just put the values. Now see here, P of A is what? So P of A, see, we have to put the values now, okay, that's why I'm minimizing it, we have to put the values that is given, okay. So this is greater than or equal to 0.75, P of A is what, friends? P of A is 0.3, write down the values, just put the values. P of B is what? P of B is 0.4, got it. P of C is what? P of C is 0.8 minus P of A intersection B, intersection B is 0.09 minus P of B intersection A, P of B intersection A 2, that is what we have to find out, right? P of B intersection A is not given, P of A intersection C or C intersection A is one and the same, that is 0.28, okay. What about this? Minus P of B intersection A, we don't know, we have to prove that itself, plus P of A intersection B intersection A is B intersection C, A intersection B intersection C is 0.08, okay. This is less than or equal to 1, this is less than or equal to 1, these are the values which you have to put, okay, these are the values which you have to put. Now on adding this 0.03, 0.3 plus 0.4, 0.7, okay, plus this is 0.7, 0.7, 0.7 plus 0.8, 0.7 plus 0.8 it will become how much? 0.7 plus 0.8, 7 plus 8 is 15, so this will become 1.5, okay, 1.5 minus this plus 0.08, if you do, on doing this you will get it as, see here you will get the value as 0.75 less than or equal to 1.21 minus, you will get P of B intersection A, okay, less than or equal to 1, you will get what? Less than or equal to 1, this is what you will have. Now it is a very important step which you have to follow, you are getting what? 1.21 here, okay, but you have to prove that this lies between 1.21 and what is it? 0.46. So for this you have to take this as the key value, okay, subtract 1.21 on both the sides, write down, very important key step, okay, subtract, now key step, subtract what is it, 1.21 on both the sides. Okay, on both the sides, subtract 1.21 on both the sides. Very important step, you have to write down this step, subtract 1.21 on both the sides. So what will this give us? So see here, on subtracting, this will become 0.75 minus, what is this, 1.21, 0.75 minus 1.21, this is 0.75 minus 1.21, both the sides less than or equal to 1.21 minus probability of B intersection A minus 1.21. Okay, you have to write it here also, then don't forget here 1 minus 1.21. This is what we have, friends. Now just you have to calculate the values, that is 0.75 minus 1.1, this will be minus 0.46, less than or equal to plus 1.1 minus 1.1, I can cancel, so this will be left with minus probability of B intersection A, this will be 1 minus 1.21, 1
Independent.
1, this will be nothing but equal to 0.21, correct, this will be nothing but equal to 0.21, get the value, direct value will get. Now see here, okay, this will be minus 0.1 because this is minus value is greater, this is what we have. Now see here, observe carefully, now we are having minus everywhere, let us remove the minus sign everywhere, so this will become what, therefore this can be written as 0.46 P of B intersection A less than or equal to 0.21. Okay, so we proved that therefore P of B intersection A lies between 0.46
Practically
0.21. Therefore we can write it, therefore P of B intersection A, P of B intersection A, what is it, what do we have to prove? P of B intersection A, P of B intersection A, see here, P of B intersection A belongs to, we can write it, you have to put it in square bracket because it belongs to, okay, that is
it
what is it, it is not
is it a G protein or is it an
equals also, so it is 0.46 comma 0.21, otherwise you can write the positive value only. Okay, see here, this will be lying between 0.21 comma 0.46, proved. Okay, this is what we have proved. Okay, this is the final answer. This is the final answer. What is our key step? So key step is what? This is our key step. Focus. Important. You are using that addition theorem. You are using addition theorem. This is also key step. So you are applying addition theorem here. Please remember this. This is the addition theorem you are applying here. Got it? This is how you have to solve this question. This is how you have to solve this question, friends. You can take a screenshot of this. Okay, and solve it by yourself. Practice by yourself again. Very important question, friends. Okay, very important question. Highly important question on addition theorem of probability. So in the previous class we have we have stated what is addition theorem and we have done the proof also. So here we are doing addition theorem of probability application of that, based on that one question has come. Okay, so total probability we solved one question, addition theorem, okay, and also application of Bayes theorem we solved one question. Now we are left with only one thing, that is conditional probability. What is conditional probability? And we also have to do what? Multiplication theorem. What is multiplication theorem? And also proof of multiplication theorem. Got it, friends? So let us do that question. I hope this is clear. Let us go back to what we have to do. Straight and proof Bayes theorem is done. See here. Now we have to do this. So they are telling what? They are telling, look at this question, very important. They was multiple times this question also. See here, they are asking what? Define conditional probability. Straight and proof multiplication theorem of probability. Sometimes you don't have to state, they will only give the statement. You have to understand that is multiplication theorem and give the proof. So please be aware of it. Okay, so let us start with this. So So we have to do what? First, conditional probability or conditional theorem. What is what they have told? First we have to state conditional probability, define conditional probability. So first of all we have to define conditional probabilities. Okay, so this question, see, first is what is conditional probability, we have to prove or we have to state. Conditional probability we have to state. Conditional probability we have to state. This is the thing we are doing. So see here, what is conditional probability? If A and B are any two events of if A and B are any two events of random experiment. What is it? Random experiment, and P of A is not equal to 0. That means P of A is, there is a probability P of A has occurred. Okay, that is what it means. Then you have to see, then probability of B, okay, after A has occurred, okay, after A has occurred is called the, what is it, is called the conditional probability of B given A, okay, conditional probability of B, okay, conditional probability of B given A, okay, given A has already occurred, okay, and is denoted by, you have to write the statement very carefully and very correctly, and is denoted by, there should not be any ambiguity here while writing the statements, and is denoted by P of B, that is probability of B,
Your time is
A,
only answer.
it is given by probability of B intersection A divided by probability of A. We use this while proving the Bayes theorem. Multiplication theorem also we use what is that, conditional probability theorem also, okay. Now conditional probability given that, okay, so where probability of A is not equal to 0, this is the meaning of it. So conditional event you have to understand, then you will understand what is conditional probability. Conditional event means what? There are two events A and B of random experiment, okay. So the occurrence of event B, given that event A has already occurred, then that is known as, what is that, conditional event. That event B is called conditional event, okay. Here also, see here, A and B are any two events of experiment, and given that P of A is not equal to 0, then the probability of B, given that A has already occurred, what is the probability that B will occur? A has already occurred, what is the probability that B will occur? Okay, so suppose you have scored 75 out of 75 in Maths 2A, what is the probability that you will get 75 out of 75 in Maths 2B also? 2A has already occurred, what is the probability that 2B will occur? That is the meaning of it, that is the meaning of conditional probability, okay. After A has occurred is called conditional probability of B, given A has occurred and is denoted by, what is that, probability of B by A, because A has already occurred, what has already occurred should come in the denominator. Probability of A given that the probability of B that A has already occurred, that is probability of B by A, that is given by probability of B intersection A divided by P of A, okay, where P of A is not equal to 0. Clear, friends? So they are asking us to state conditional probability. Is the meaning of conditional probability.
Responsive genes contain 6 new.
So let us go to the, what is the next, multiplication theorem. Let us go to multiplication theorem, statement and also proof. Multiplication theorem, very important. Multiplication theorem, okay. So see here, multiplication theorem states, okay, if A and B are any two events of random experiment, same thing, okay, of random experiment and of random experiment, okay, and now comes the important condition, and P of A is greater than 0 and P of B is also greater than 0, then now by multiplication theorem what happens? So by multiplication theorem what happens? P of B by A, if I write P of B by A, or if I write P of A by B, anything, P of A by B if I write, so this will be equal to P of A, okay, this will be equal to what? P of A into P of B by A. Similarly, this will also be equal to P of B into P of, what is it? P of A by B, okay. This is as per what? This is as per multiplication theorem of probability. Multiplication theorem of probability. Okay, this is what we can do. Okay, this is multiplication. If A and B any events of experiment and given that P of A is greater than 0, P of B is greater than 0, then P of A by B is given by P of A into P of B by A. Okay, this is what we can do. So this is what we can do. So here it should not be P of A by B. This should be actually P of A intersection B. Okay, this should be actually what? This should be actually just you have to make some change here. This is not P of A by B. This should be actually P of A intersection B. P of A intersection B. This is what we have. P of A intersection B is equal to P of A into P of B by A. Okay, or this will also be equal to P of B into P of A by B. Okay, so let us go for the proof now. Okay, let us go for the proof now, friends. What does the proof says? Okay, proof of multiplication theorem. Okay, proof of multiplication theorem. Let us go for the proof. proof. So let S be the sample space of a random experiment, sample space of random experiment, and A comma B any two events within the sample space X, within the sample space, same sample space, within the sample space yes, okay, sample space yes, given that such that, instead of given that we have to write such that P of A is greater than 0 and also P of B is greater than 0. Okay, then let us apply, what is that, what we will apply, let us apply, see here, let us apply conditional probability. Okay, let us apply conditional probability here. So see here, so such that this is the thing. Let us go to the next page. Then by conditional probability, okay, we have, what is that, we have P of, okay, P of what is that, we will write P of B by only, probability of B given that A has occurred. Okay, that is conditional probability, that is what conditional probability says, is given by P of B intersection A divided by P of A. Let us write this as equation 1. Now let us go to the next page, friends. Okay, now replace, now what we have to do, now replace B by A in equation 1. We get what, we get R. We have to do here, we have to do some more modifications here, directly we cannot do it. This is what we are, let us not write this as equation 1, let us do some modification, because we have to get what, B intersection A. Okay, so we will write what here, let us go to the next page, we will write here, see here, now this implies what I can write, I want P of B intersection A, so this and this I can multiply, cross multiply, so this will become what, P of B intersection A will be equal to P of B by A into, what is it, P of B by A or P of A by B, P of B by A into P of A, or I can write it as P of A into P of B by A, P of A into P of B by A. This is what I have. By what? By conditional probability. Now replace B by A in equation 1. Let this be equation 1. This is equation 1. We get what? P of A intersection B, or I will get it as P of B intersection A. Okay, if I replace A by B, this will be equal to what? P of B into P of A by B. This is equation 2. So from 1 and 2 what I will get? From 1 and 2 I can write it as, so from 1 and 2 I can write it as what? From 1 and 2 we get what? P of A intersection B is equal to P of A into P of B by A. First equation. Second equation says that this is also equal to P of B into P of A by B. Okay, therefore we get, okay, this is what we will get. This is nothing but what? Multiplication theorem of probability. This is what? Multiplication theorem of probability. Highly important. Clear? So multiplication theorem of probability, this is what it says. Okay, this is what it says. So when we talk about multiplication theorem of probability, you have to keep this in mind. P of A intersection B, P of A into P of B by A. So P of B by A is nothing, P of B by A, this is equal to P of B into P of A intersection B. This is what multiplication theorem of probability. So we are done with probability. First is addition theorem, Bayes theorem, then conditional probability, multiplication theorem we have done, and also one question on total probability, then application of Bayes theorem we have done, and also one question on addition theorem of probability we have done. Okay, clear friends? So Bayes theorem I think we have done 3 questions. Okay, so this is more than enough, sufficient for you to get full marks from the questions, large LAQs from pertaining to probability questions. Okay, probability chapter. Alright friends, we will wind up now. In the evening session, we will be doing 2B. We will be starting with very important chapter, integration. Alright friends, thank you. Take care.